Let's start at the beginning with talking about what statistics are. So before we get into anything else, just what do we mean by statistics? And statistics then are essentially anything where we quantitatively summarize information. So it's a quantitative way to summarize data, numbers, and so we use these numbers to really describe anything. You can describe almost any variable in a quantitative way, whether it's counts of things or describing variation. But we can describe the world. We can describe crime rates. We can talk about likelihoods of victimization or likelihoods of criminality. We can talk about what increases recidivism risk. We can talk about a lot of those things that are super relevant to sort of everyday life as a criminologist or working in the criminal justice system. And I've got the numbers up here. If you've never seen this show, it's an amazing show, and I highly recommend it, where they literally use math to solve crimes, and it's pretty awesome. So we have certain statistics that can be used for populations and samples, and ones that can be used for only samples. So populations are essentially the entirety of the group that you want to talk about, whether it's all Americans or all criminals in a certain state, or all violent criminals, or all property criminals, or whatever you want to talk about. And it can also be smaller, like if we want to talk about all students at a certain institution, or all college students in the state of Montana, let's say. So that would be our population, but our sample is, by definition, almost always smaller than the population, because the sample is the group of people that you're actually gathering information from, whether that's through interviews or surveys or observational or whatever other way you're getting information from them. The only time populations and samples are going to be the same is in a census, because in a census, by definition, you're doing a count of the entire population. So your sample and your population would be the same. But any other situation, and kind of the way that we use statistics most often, is because we have a small sample and then we want to talk about a larger population. So we can use some statistics directly for populations to talk about things like descriptive measures, and so using something like census data, or even just being able to talk about population rates of things. But more often we're using samples to express the likelihood that a sample estimate is about the same as the real figure that we really want to know in the larger population. And so essentially statistics help us to understand everything around us, because when we quantitate things, when we make things quantitative, when we quantify things, that's the right word, we can do so much with that. We can see patterns and develop relationships and sort of see what is going on between a host of different variables. So there are three types of statistics. And actually that graphic there has the guy looking at the book that says How to Lie with Statistics. There actually is a book that's called How to Lie with Statistics, and it's pretty cool because people try to do that all the time. But anyway, so there are three types of statistics. We have descriptive statistics, we have inferential statistics, and we have predictive statistics. So descriptive statistics are kind of the most basic, kind of the first step that you would do in any study is going to be to describe what's happening in your sample. So typically descriptive statistics are univariate, meaning that we're looking at one variable at a time. So we want to present, what this variable looks like. What's the shape of this variable? What does it look like? So for example, a pie chart saying, 47% of our sample is married, 33% are single, 12% are divorced, and 8% are widowed. If that was true for the marital status of our sample, that would be a descriptive statistic of our sample for that particular variable. And then we probably have a host of a bunch of other different ones, and like the age ranges and racial makeups and maybe religious views or victimization or criminal history, depending on what we're looking at. So we want to describe our sample, basically saying what's going on with each of the individual variables. And so you can use graphics like pie charts and bar charts and any histograms, anything else, but you don't have to. You can also use numbers. So we could take that pie chart and put it in a table and have all those numbers, and it would be the same information. It would just be described a little differently and be presented a little differently. But descriptive statistics are the way that we describe, we have a whole bunch of numbers and we want to start by seeing what's going on with those numbers. So typically we use descriptive statistics In exploratory research, that might be where you stop, but also this would be the early stages of research, of any kind of research study. So even if you're going farther, you start with descriptive statistics to say what's going on with your sample, what does it look like, what's the inclusion criteria, who's there, what does our sample look like, and then you go on and do some further steps. Although if you're doing exploratory, it might be just about you want to know what does this sample look like and what do the people that you're specifically looking at for whatever exploratory reason, what do they look like? So then we have inferential statistics. And so inferential statistics, essentially they're looking at differences between groups or classes, between different things. So you're starting to make comparisons. So typically this results in either bivariate, meaning you have two variables that you're comparing, sort of see how they relate, or multivariate, where you're having more than two. And so you're seeing sort of how a bunch of different variables all in one big analysis, how they interact with each other and how they affect each other, etc. So inferential statistics are also known as measures of significance, because they are measuring whether there are statistically significant differences. And p-value is a big part of that, which is why I have my p-value smaller than your p-value, because a small p-value is actually very, very good. That means it is statistically significant in terms of the difference that whatever your difference you're comparing. So when you're comparing two groups or sort of comparing two different measures, then a significant difference means that there is a real relationship going on. There is some kind of relationship that is, where X is associated with Y. So there is a statistically significant relationship between poverty and likelihood of criminality. There is a statistically significant relationship between, social disorganization and crime. So when you have, and those will both be bivariate measures. So if we start to throw in multivariate measures, maybe we have multiple measures of social disorganization. So we're looking at, poverty plus the residential mobility, people moving in and out, plus the heterogeneity of your population. So we're going to have a couple of different, maybe even multiple variables to measure each of those things. And maybe we'll have 6 or 7 variables, and we want to see how all of those are related to the crime rate in the area. That would be a multivariate analysis. But we're always looking for measures of significance. We're looking to see if the p-values are small enough to show that there's something real going on. Because if they're not small enough, then that means that there is a large enough likelihood that this could have just happened by chance that we can't say that it's a real relationship. So typically we use inferential statistics in like the end stages of descriptive research, maybe where we're trying to explain something, maybe if we're talking about causality. That's where we're going to be using inferential statistics. And then predictive statistics are kind of we're going another extra step. So we're dealing with relationships, so we're going to have correlations between variables, and we're going to have, so beyond just there is a significant relationship here, what does that relationship look like? This is kind of the next step in the predictive statistics, is that we're going beyond just does a relationship exist to what does that relationship look like? And so we can use predictive statistics to look at how strong a relationship is, and then we can, because there might be a statistically significant relationship, but it might still be a weak relationship. So you could have a weak relationship that is still statistically significant. So it's important then is to know how strong the relationship is, the direction that the relationship goes in, because you could have, as one goes up, the other goes up, or as one goes up, the other goes down. So you can have different types of relationships. And then once you know the strength and the direction of your relationship, you can start forecasting, you can start predicting, which is kind of the whole point of predictive statistics. You want to be able to say, well, if this is true, then this is true. And so this is where we can really establish covariation, so how things correlate, how things are related to each other, to really talk about causality. So we can kind of talk about it a little bit with inferential statistics, but you have a lot more on your side, I guess a lot more evidence when you have predictive statistics, because the more information you know about that relationship, the better you can explain it. So typically this is used in explanatory research, so when we want to explain something. And you might not be able to kind of see the little picture there, but they've got a whole bunch of math on the chalkboard, and that says that a miracle occurs, and it says, well, I think you should be more explicit here in step 2, because miracles sometimes feel like they happen in math, but they are actually all very explainable. So those are like the 3 main types of statistics, and so you want to have a good kind of knowing how we would use each of these, is how we're relating it to kind of knowledge, or, you know, how would you take those numbers, how would you take these statistics and actually apply them in, like, to answer whatever question it was that you originally posed. So each type of statistics answers one of 3 types of questions. And you would ask these questions in a certain order that makes sense in terms of if you're trying to figure something out, you're going to ask them these questions in a certain order. So starting with descriptive, what are we looking at? What's going on here? What's this? So just we need to describe what's going on. And then the inferential, well, how is this different from other things that may seem the same? So how is this different? Is there a difference? And then predictive, well, how do we predict and explain this phenomenon? So that's that final step to really, when you really understand something, to be able to say, okay, now we can predict it. Now we know what's going on enough to be able to say, here's the pattern, and here's how it would be used outside of what's going on with, you know, just our sample or just in our population even. So those are the 3 different types of statistics.